Kirkle Math. Welcome, ladies and gentlemen. We are starting Module 9 and 10. We are looking at Lesson 9.1, Translations. This is a new topic for you guys. We're doing some geometry. In this topic, you're going to learn how to translate a figure given a description and write an algebraic expression of that translation. So what even is a translation? Well, a translation is a type of transformation. So go ahead and write all of these colored words on your notes. You can go ahead and pause if you need to. It is a lot of words, but it's a lot of new information that we are learning and working with. A transformation is a type of function. So if you remember, we looked at functions. They were like different graphs, and we were looking to see if the 2 points on the graph were the same x value. And if it was no, then it was a function. And if it was yes, it was not. Well, translating something or transforming something is really a function. It has an input and an output, and it describes a change in the position, size, or shape of a figure. And we're going to learn about, 3 or 4 different types of transformations, and each one will change either a position, a size, a shape, or more than one thing. All right, so what we see here, some words we need to know about transformations is that transformations have pre-images. That's our input into our function. It's the original image, and we just use regular letters to label that shape. So over here in our example, you would see that this here is a pre-image, triangle ABC. The image is our output. After we've done the thing and slid or flipped or rotated the shape, you get an image. That's your new image, and we label it with A prime, B prime, C prime. We label it with letters and then an apostrophe after it, which we say as prime. So here you can see the pre-image was translated to this image, and we have this image of A prime, B prime, C prime. This is triangle A prime, B prime, C prime. So we translated this image and actually slid it across. There's lots of transformations. They all have pre-images and images. Now, when we transform a shape, we have to wonder about its congruence. Is the pre-image the same size and shape as the image? Translating, which we're doing today, does maintain the congruence of a shape. That means that when I slide the shape around, it's going to have the same size and shape as the original image. Something else we need to think about is the orientation of a figure. Did I flip it upside down? Did I rotate it in a circle? Did I turn it in any way? If the original shape is in the same direction, facing the same direction as the new shape, then the orientation of the figure was preserved. So the orientation is the direction a figure is facing on a coordinate plane. And again, translating a shape, we do preserve the orientation of a shape. We can slide it across, but we're not flipping or rotating yet. So now here we are. We've been talking about translations, but what even are translations? So a translation means to slide each point of a figure the same distance and same direction. So a translation is a slide. Now I could take the smiley face and slide it left and down, down and left, or I could slide it kind of diagonally. But either way, it's a slide. You can probably see from this image that this smiley face is the same size and shape as this smiley face. And this pre-image is also facing the same direction as this pre-image. The little whites of the eyes are on the right-hand side in both images. I didn't flip it or rotate it either. All right, over here we have algebraic representations or equations that you can kind of memorize, or we're going to need to know how to write. If I want to translate something to the right, I'm going to add that number to x because I'm sliding it on the x-axis to the right, positive. If I'm translating something up, I'm going to add that value to y because I'm moving up on the y-axis. If I'm translating it left, I'm going to do the opposite and go minus a to x. If I'm going down, I'm going to minus b on y. So make sure you have those notes down. We're going to show you how that works. Okay, so here we have our figure. XYZ, we have our triangle XYZ, and we're going to graph the image of the triangle after a translation of, so we know we're sliding 4 units to the right and 1 unit up. Okay, so I am going to basically just count 1, 2, 3, 4 to the right, 1 up. 1, 2, 3, 4 to the right, 1 up. 1, 2, 3, 4 to the right, 1 up. So if I go 4 to the right and 1 up, then my entire triangle is now translated 4 units to the right and 1 unit up. Now my triangle looks a little funky because it's hard to draw on this computer screen, but you can kind of see that these are the same shape, same size, same direction. I just slid it over and up. Now, I can do this easily on a coordinate plane by counting, but something I'm going to want to do is be able to explain to somebody in an algebraic way what happened to my x and y coordinates of each letter. And so the way we do that is we show it with that thing we did on the last page in the table. Because I'm moving it to the right, I'm going to add 4 to the x value. Because I moved it up, I'm going to add 1. I moved it up 1. I'm going to add 1 to my y value. And so if I actually look at each coordinate on my triangle and I apply this algebraic equation to each point, I can translate this without even using a coordinate plane. And I can tell you the new value of x prime and y prime and z prime. So I'm going to do it with at least one of these here. So we're going to look at the letter x here, this x right here. The coordinates of x is -4, +1. I'm going to now translate it and do the algebraic representation over here. So I added 4 to x and I added 1 to y. Whoopsie, I need to write the actual value of y. And I added 1 to y. So -4 + 4 is 0. And 1 + 1 is 2. So the new value of x prime should be 0, 2. And if I look at my graph, 0, 2, that is correct. And that's how it works, guys. It's relatively simple. We're going to do some more. All right, we are translating this parallelogram PQRS, 4 units left and 2 units down. So I'm going to go ahead and write my algebraic representation first. So because I'm going left, that means I'm going negative on x. I'm going to take away 4. And because I'm going down, I'm going to go negative on y because I'm going down and taking away 2 on my y. 4 on x and 2 on y. So now that I have that written out, I could apply it to each coordinate and slide it over, but instead let's go ahead and count and see where we are. Let's see, 1, 2, 3, 4, 1, 2. So this is Q prime. 1, 2, 3, 4, 1, 2. This is P prime. 1, 2, 3, 4, 1, 2. This is R prime. 1, 2, 3, 4, 1, 2. This is S prime. And then I just have to connect all of my points. Bam! And I have now officially translated this parallelogram, PQRS, to this parallelogram, PQ prime, Q prime, R prime, S prime. Now again, remember, we said that when I translate, my shape is congruent. Now I can kind of tell that this is the same size and same shape, but obviously since I'm drawing it by hand, it might look a little different. So how can I double check that this is truly the same size and the same shape as my original figure? Well, one way would be to count, okay? This size from Q to R is 3 boxes. If Q prime and R prime are 3 boxes, I know that side is congruent. The side P to S is 4 boxes. If P to prime S prime is 4 boxes, I know that's congruent. I can even start looking at pieces like measuring parts of my shape. From P to the right side is 3 boxes. From P prime to the right side is also 3 boxes. So by measuring the parts of my shape, I can pretty much tell that yes, this is congruent. They are the same size and the same shape. All right, now you're going to go ahead and do these translations, and you can come back and see if you got them right. Don't forget to give me that algebraic representation or equation. So tell me, how is it translating, and describe algebraically. You also might notice, maybe if you're doing this early on, that your graphs might be flip-flopped. Just go ahead and make sure that you're using this graph here with A at 0, 3. And then on this problem here, where you're translating 5 right and 3 up, you're using the one where A is at -5, 1. And that'll just make it easier while you're translating. If you do it wrong, that's okay. Just, you won't get the same answers as me. All right, I'd pause the video and try it out. All right, so your algebraic representation of this is x minus 5, y minus 2. And when you translate, you should get yours over here. So A goes from being at 0, 3 to being at -5, 1. And then on this one here, we have algebraic representation of x plus 5, y plus 3. And we go from -5, 1 for A to 0, 4 for A prime. Okay. The last one you're going to do is just take a look at this hot air balloon. You need to describe the translation and do that algebraic representation, x and y. I would probably pick this point right here on your hot air balloon, and we are going from the lighter air balloon to the kind of faded air balloon. So describe that transformation, okay? Take a pause, describe that transformation, come back and check. 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5 up. So that's going to be +4 + 5. And we're done. I highly recommend, if you haven't, I should have this video in my YouTube channel as well. It just kind of explains translations again and in a little animation. And I think it's only about 5 minutes, 5-6 minutes. I think it's a good visual, especially if you are struggling. Enjoy.